Hello students, we are going to learn in this video about the basic RSA algorithm, and then we will see one of the examples for the RSA algorithm, how we are going to calculate the value of D and how we are going to calculate the value of various parameters that are used in the RSA algorithm. So first of all, let us go and study about the RSA algorithm, and we will check what are the values, different values that we actually have in an RSA algorithm. The RSA algorithm actually have 5 steps. So we will have an RSA algorithm page. We will be using we can say a 3 column table to actually demonstrate what we actually want to state here. Okay, the thing is, the first thing is the steps that we will at the RSA follows. The second are the values that are the examples, and third are the remarks that whether a particular parameter is a public parameter or a private parameter. The first thing is well, first thing is we select two prime numbers p and q, okay, such that p is not equal to q. This is the first step that we actually have. So let's suppose p is 13 and q is uh, 7. So these are two prime numbers that actually are considered for this RSA example. But there should be a note that in actual cases these prime numbers are not so trivial, they are not so small, they are actually big numbers, and the reason is, if you have big numbers, calculating the inverse or calculating the factors of those big prime numbers are very really difficult. So the first thing is p and q are private to the users. So it is private variables. So that means only the sender and the receiver knows about the p and a q value. The second thing is, based on the p and q, you calculate the value of n as p multiplied by q. That means what you do is you will calculate the value of n as 13 multiplied by 7, that comes to be 91. Okay, and now this n, it's public in nature, it is public in nature, which means it is known to all the recipient, including the sender and the receiver. Okay, now the third thing is calculation of the set of co-prime numbers, that is phi of n. Okay, this phi of n is calculated as, because n has factored into, we have phi of p minus 1, phi of p multiplied by phi of q, and because p and q are both prime numbers and they are raised to the power of 1, we can write this as p to p minus 1 multiplied by q minus 1. Okay, so in that case this phi n will come out to be 13 minus 1 and 7 minus 1, that is 13 minus 1 is 12, 7 minus 1 is 6, that is come to be 72. And this phi n now is a private variable, private parameter. That means only a sender and the receiver knows about this particular phi n. Now coming to how, I believe everybody knows about how we calculate phi n, but as of now, for those who doesn't know how we calculated phi n, why we have p minus 1 and q minus 1, let me demonstrate once again that what was the value, how we calculate phi n. So phi n is calculated as, suppose the general formula for phi n is, suppose we have phi of p to power a. This is the general formula, for phi. So if it has three conditions, the first condition says, if the value of this p is prime, if the value of this p is a prime number and a is equal to 1, then the value comes out to be p minus 1. Okay, this is the value that comes out to be p minus 1. So you can take example of phi of, say, uh, 3, 5 of 3. 3 is a prime number and the raised to the power of 1. So we get 5 of 3 minus 1, that is 2. Okay, this is the value. Now coming to the second thing, when p is prime, when p is prime and a is not equal to 1. Okay, suppose this is something like this, 5 of 5 to power 2. Okay, in that case what can be the answer? Okay, what will be the formula? The formula will be p to power a minus p to power a minus 1. Okay, this is the formula. Now if you check this formula and you put a is equal to 1, you will get this form derivation. When we put a is equal to 1, this is p to power 1, that is p, and p to power 1 minus 1, that is 0. P to power 0 turns up to 1, then this term will be reduced to 1 and this term will reduce to p. So again you will get the same thing. So in this what you will get, it is, if you put the same value, 5 to power 2 minus 5, that is 25 minus 5, you get 20. So this is the value of 5 for the second. Now the third case is, suppose p is not prime, p is not prime, right? But a is equal to 1. That in that case what will be the value? Suppose the value of phi is 24, right? Now this p is not prime but the value of a is 1. Then that case what I can do, I can write it as phi of 8 into 3, right? This is what I can write, and then I can rewrite is phi of 2 to power 3 into 3. Again prime factorization, 2 to power 3 and 3 to 2 raised to power 1. Then I can use the same formula. This thing goes with the second formula, second structure, like this, when p is prime and a is not 1, and this thing goes with the first, when p is prime and a is equal to 1. So we will, what we will do, we will have phi of 2 to power 3 minus 2 to power, the value will be 3 to power 2 to power 3 minus 2 to power 2 multiplied by 3 in minus 1. Okay, this will be 8 minus 4 multiplied by 2, and that is 4 multiplied by 2, that is 8. So you have a value called 8 here. Okay, so the general formula for this one will be, the general formula for this one will be, you have to divide it into two prime numbers, x to power a and multiply y to power b, when x and y both should be prime and a and b should not be equal, should be equal to may be equal to 1 or 2, not be equal to 1 or 2. You can't say anything about this, but these two should be prime. So we will use this formula phi a for calculating this. So with the help of that formula, we actually know 13 is a prime number and 7 is a prime number, and both are raised to the power 1. That's why we use 13 minus 1 and 7 minus 1. So this is, I hope this is clear now. Now the next fourth step is to calculate the value of E such that E has two conditions. One is E should lie between 1 and phi of n, and secondly E and the GCD of E and phi n should be 1. So these are the two conditions. Okay, based on this we calculate the value of E. Suppose we choose the value of E to be 5. Okay, this is how we choose a value, so that these two conditions are always met. Okay, phi n is 72, E is 1, and then we have phi n and E, the GCD should be 1. We have to check whether the GCD of 5 and 72 should be 1. So we will confirm this, but this E is now public value. This E is a public value. Now after this, what we do, what we check after this, we will have to check the fifth step is to check about the fifth step is to calculate the value of D. The value of D is calculated as D to power minus 1 mod times phi of n. Okay. of d is calculated as 5 e to power minus 1 mod times n. What is this value comes out to be? This is the formula. So this formula calculated e we have selected as 5. 5 to power minus 1 mod times what is phi n? Phi n was 72, and this particular d is private in value, right? This is only known to sender and the receiver. So this is the 5-step process for calculating the value of d. Like, so in this we actually calculated the value of n. The n was 91. The phi value of phi n was 72. The value of e was taken as 5. Now we should know how to calculate d. The d is a private key, and that this thing we can understand in this way, that this says that e into d mod times 72 should be congruent to 1. So this is what it actually says, right? And that's why we say d is equal to e inverse mod times 72. Okay, this is how we derive the value of d. So we need to find a value of d such that e inverse mod 72 should be 1. So we can use something called back substitution method, right, for calculation of d. So in back substitution what we do, we will take, if we have something called 5 inverse mod of 72. So this is the domain and this is the number that we want to find the inverse of. So we will write the equations like this is the mod. Mod should be divided in terms of the number. 5 times 14 is 70 plus 2 is 72. Now what we do, we will shift this 5 to the right side of the left side of the equation. So this becomes 5. We put an is equal to, we move this 2 to the first place, we need 5. So we will have 2 times what? 2 times 2 is 4 and plus 1. Okay, we have told you in the class, and again we are telling you here, that you will stop at this 1. Why we stop at 1? The reason is this 1 signifies, if you get a 1 in the equation, it signifies that there is an inverse. That means this shows that the 72 and 5, the GCD of 72 and 5 is 1. That means the inverse exists. Okay, the inverse exists. So we actually find out that the inverse of the number exists with the help of this equation, back substitution method. Now let us let us find out the inverse so that we can find out the value of d in this equation. Okay, now what is the value of d in this equation? So now we will rewrite the equations. What is the equation? We will start with the first equation. We say we will write it like 5 plus 2 times minus 2 is equal to 1. This is, we can write it like this, 2 times minus 2 is equal to 1. So in this equation I have this 2 here, right, and the same 2 can be replaced from this 2. So what we actually can do here is, we will write this 2 as 72 plus 5 times minus 14, right? This is the 2 value. So we have replaced this 2 with this complete equation, and again now I can go back with the same equation, 5 plus, this was the initial thing, and this minus 2 now is again and tag is equal to 1. Okay, now when we solve this equation, I get 5 plus 72 times minus 2 plus 5 times 28. Okay, 5 times 28 is equal to 1. This is what we have got in this. Okay, so again we will rewrite this thing. We will check what was the equation. It says it was 5 times 72. 5, it is 5. Okay, it is 5 plus 72 times minus 2 plus 5 times 28 is equal to 1. Okay, so you have 5 times 29 plus 72 times minus 2 is equal to 1. So if we take mod of 72 both the sides, okay, this is mod of 72 both the sides, we will take both the side, what will happen? We will have 529 mod of 72 plus 72 minus 2 mod of 72 is equal to 1 mod 72. Okay. Now, when you have a 7 number, the domain itself in the number, this term turns out to be 0. This term turns out to be 0. Okay. Now, what is left with you now? What is left with you is 5 times 29 mod of 72 is equal to 1 mod of 72. So we can see the initial equation that we have here. It says this is the initial equation. 5 times something mod 72 should be equal to 1. 5 times something mod of 72 should be equal to 1. Now if you see both the equations, this is, you can easily correlate that this is the value of D. Okay, so we find out the value of D as well. The value of D comes out to be 29. So in the next video, we are surely going to see how we are going to use these values of E and D and phi n to actually find out the value of the convert that particular plain text to a ciphertext and ciphertext back to plain text.